In this video, we're going to use OscarSyn to look at the various synthetic reactions that you can do with enamines. Now here we got we set up to make an enamine. We've got our disubstituted amine and a ketone, and we got some catalytic hydrogen. So let's go ahead and do the reaction. Here's our enamine, and of course we get the least substituted one, as we discussed in the previous video. Now this is a bit like an enol, except of course we have a nitrogen. And we can use the double bond as a nucleophile to do SN2 chemistry if we've got a reactive substrate. So let's just do something simple. We'll use a bromide, and we'll just do a simple let's just do a simple propyl group and see what we get. Well, we get this iminium ion, where what's happened here, of course, is the double bonds come around, kicked out the bromide from the backside, and as you're doing that, of course, the nitrogen lone pair is actually pushed the whole thing on its way and formed that double bond. So this is an iminium, and these things can be taken back to the ketone simply by hitting them with aqueous acid. So let me get a little acid here, and we will press the magic button and get back our ketone and free up the original amine. Now this is a very nice synthesis, and you can use all kinds of reactions, various substrates in doing this reaction. And so let's just try some other ones. What else could we put on there? We could oh, I don't know. Let's do a benzyl group. So let's say we have a benzyl group. The benzyl is always very good in SN2 chemistry, and well, I didn't do that right. Still I didn't do that right. Let me start over. Okay, bromide, carbon, go down, grab my phenyl, press the button. So there's well, that's drawn kind of weird. Let me redraw it. I use the magic wand up here and ask Oscar to redraw it. Ask him to redraw it again. Ah, boy, this is a weird looking molecule. There we go. There we go. He had everything overlapping. So here we go. Here's our iminium ion, and of course, again, we hit this with aqueous acid. Get a little acid in here, and we can go to our free ketone. So there's our here's our amine back, and here's our final product, where we've ended up basically putting the benzyl group on the side over here. You can say, well, why not just use LDA to do this? Well, the whole point is this avoids the LDA, and these are all much more milder conditions, which you can imagine if you're doing molecules which have more sensitive substituents in it, would be a real advantage. It also, you know, it's kind of like where, you know, think ahead to biology, where we want to be in more of a more aqueous world. Now, one other neat reaction that you can do with these things is this nucleophilic character of the enamine allows them to take part in conjugate additions. So let's do a conjugate addition, and for a conjugate addition, which of course we want is a double bond next to a carbonyl. So let me draw out this methylvinyl ketone as kind of the prototypical example. And what's going to happen here? Well, again, the nitrogen lone pair will come in, form a double bond there, form an iminium. The double bond will reach over here, attack the carbon, move the double bond over, move it over here, we'll get an O-. Then everything, well, then there'll be a proton, come around, rearrange, and we'll have our magic molecule. And what do we get? Well, we get this guy. So what is this? We've added the group over here. The double bond has moved away as this thing tautomerizes back, and it's still an enamine. And in this particular case, now I've drawn the enamine on the other side, and actually it could go either side here because this substituent pattern is basically the same. But since this group's a little bit smaller, I stuck it on the left over, or Oscar stuck it over on the left. Oscar got to choose, and Oscar put it on the left over here. So this is a good mechanistic problem that one could do. And of course, again, we can still get back to our ketone if we want by adding some aqueous acid Um, and so we'll work this up. And there's our free ketone. And again, our nitrogen back. So here we now have a diketone. And, you know, if you plan your syntheses right, you can do some fairly sophisticated things. In principle, up here, if you got this enamine clearly on one side, you could alkylate here as well at this species. So there's a lot of chances to do creative things in this chemistry.